Hello students, welcome back. So in this lecture of physics we are going to continue our second chapter, that is units and measurement, and our today's first topic is dimensions of a physical quantity. So as I told you in my earlier videos that we have 7 fundamental quantities, that are mass, length, time, temperature, current, luminous intensity, and last one is amount of substance. So it's obvious that it also have the dimension. So for dimension we used a bracket to represent that they are the dimension, and for mass we used a symbol, that is m. For length we used a symbol L. For time we used T. For temperature we used K. For current we used A. For luminous intensity we used CD, and for amount of substance we used mole. So through these symbols we can represent the dimension of the physical quantities. So first of all I am telling you the definition of dimension. So the dimension of a physical quantity are the power or exponents to which the units of base quantities are raised to represent a derived unit of that quantity. So the definition is a little bit complex. Let us understand with the help of an example. So if we're talking about the area, so what is the SI unit of area? That is meter square. And if we talk about the SI unit of volume, that is meter cube. So what you are notice here, that in area we have the power of meter is 2, and in volume we have the power 3. So these powers are known as the dimensions. I hope I am clear with the dimension. So in mechanics, all the physical quantities can be written in terms of dimension of L, M and T. So let us understand this help of an example. So what is the formula of volume? Length into breadth into height. So therefore length will be L, breadth will be L, and height will be L. So this all combined will give you L raised to power 3. So represent volume, we have raised L to power 3. So as the unit of mass and time are not required in volume, so we can put their dimension 0. So the final dimensional formula for volume will be M0, L3 and T0. This is the final dimensional formula of volume. So now let's discuss more about the physical quantities. So here we will make 4 columns, in which first is physical quantity, second is formula, third is dimensional formula, and fourth is SI unit. So our first physical quantity is area. So what is the formula of area? That is length into breadth. So we can easily say that would be L into L. So therefore it will be L raised to power 2, and the final dimensional formula will be M0, L2 and T0, and the SI unit for this is, as we all know, that is M square. If we talk about volume, the formula of volume, length into breadth into height, so it will be L into L into L. Therefore L cube, and the dimensional formula for this is M0, L3 and T0, and SI unit is M cube. Third physical quantity is speed. So the formula of speed is distance by time. So for distance we use L, for time we use T. So therefore it will be L1 T minus 1, and the dimensional formula will be M0 L1 T minus 1, and SI unit is meter per second. If we talk about the velocity, so velocity formula is displacement by time. So for displacement we use L, for time we use T, so that will be L1 T minus 1, and the dimensional formula would be M0 L1 T minus 1 in meter per second. The SI unit of speed and velocity is same. If we talk about the acceleration, that is, formula of acceleration is change in velocity upon time. So we know that velocity dimension is Lt minus 1 and time is T. So the final formula will be L1 T minus 2. So the dimensional formula would be M0 L1 and T raised to power minus 2 will be meter per second square. If we talk about force, the formula of force is mass into acceleration. So for mass we use m, and we know about the formula of the dimension of acceleration, that is L1 T minus 2. So the dimensional formula for force is m1 L1 T minus 2, and the SI unit of force is Newton, or we can also say that kg meter per second square. So this is the one of the important dimension. So please learn the dimension of force. Our next physical quantity is energy. So for energy, before discussing energy, let me come to work. So work is basically force into displacement. So the dimension of force is m1 L1 T minus 2, and we will multiply it by displacement. It will be L. So the dimensional formula of work is m1 L2 and T minus 2. Work is measured in joule, or you can say kg meter square per second square. So energy is also work. So it would be same as the formula of work, or and the dimension we will get is similar to work. So the SI unit of energy is joule. So this is enough for today's video, and we will continue this topic in our next video. Thank you.